Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. We are still in chapter 1. We have done section 1.1, set, subset and set operation. Now we continue to section 1.2, which is laws of set theory. For any sets A, B and C taken from a universe, law number 1, A double prime equals to A. This we call law of double complement. So we can prove this law by using a Venn diagram like this. Draw a rectangle for universal set and circle for set A. We know that the region outside the circle is for A prime. Similarly, the region that other than A prime is the complement of A prime. That is, the circle is A prime prime, which is equals to A. Okay, law number 2 up to number 10, each one has two parts: union and intersection. Okay, law number 2. This we call De Morgan's law. For De Morgan's laws, A union B and then bracket prime. Like the one A intersection B bracket prime. So De Morgan law changes union to intersection and gives each set a prime. So here, union changed to intersection, intersection changed to union. Law number 3, commutative laws. Commutative laws, A union B equals to B union A intersection B equals to B intersection A. Law number 4, associative laws. So for associative laws, you must observe about the operation. Okay, same operation, union, and this also union. The outside union, inside the bracket also union. Okay, intersection also the same, outside intersection, inside the bracket intersection. Right, you can prove this law by using a Venn diagram like this. Okay, like this one. Right. So associative law, you just change the bracket. Because of same operation, you can change the bracket. Distributive laws also have two. One for union, the other one is for intersection. So for distributive law, observe that there are different operations. Outside the bracket, union, inside the bracket, intersection, or outside the bracket, intersection, inside the bracket, union. And all the three sets are different. Look here, A, B, C. Okay. So this one also you can prove by using a Venn diagram like this. Law number 6, we call idempotent laws. A union A equals to A intersection A equals to A. Law number 7, identity laws. Identity laws, when you perform the operation, it gives the set itself. A union empty set equals to A intersection universal set also equals to A. Law number 8, inverse laws. Inverse law, A union A prime. So this equals to universal set, and A intersection A prime equals to empty set. Law number 9, we call it domination laws. So domination laws, A union universal set equals to universal set. A intersection empty set equals to empty set. And last law, which is 10, law number 10, we call it absorption laws. Okay, absorption laws also have different operation. union, and intersection. But for absorption law, this one is equal set. See, A and A. So different with distributive just now. Okay, distributive, all three sets are different, even though we have here different operation, union and intersection, right? All different sets, But for absorption law, the outside set and inside set, we have same set. Okay, same set. So same goes to this one, A intersection and a bracket A union B. The answer is A. Okay. Okay, let's look at some examples here. Simplify the expression. To simplify this expression, first you look at, okay, is there any bracket? Yes, we got this big bracket, and then have prime, 1 prime. So first step, you should open that bracket. When you open that bracket, it will give alright, each set. Okay, suppose that this one is like A. It's like A. So each set have 1 prime, and union change to intersection by De Morgan's law. Right? So this double prime. So by using double complement, we can get this the next statement. And then after that, using associative law. Because of same operation. Same operation, right? Can you see this? Intersection, this also intersection. Then you change the bracket. Right? After that, using a commutative law, commute B and C. Once again, we use associative law because of same operation here. And then you just change the bracket. Can you see this? Different operation, but we have same set. So we can use absorption law. So the last expression simplify as B intersection C. Okay, go to next example. This one, to prove left hand side equals to right hand side. So first you look at left hand side. We start with left hand side. Right. This symbol is for relative complement. It's for relative complement. So we have a definition of relative complement: A intersection B prime. So change this to its definition: A intersection B prime. Then right, prime still there. Then you open this bracket, because have a prime outside the bracket. Open the bracket. So by De Morgan's law, change intersection to union and gives each set a prime. And then using law of double complement, because have double prime here, so we have reached this right hand side. The next example, also to prove left hand side equals to right hand side. So we start with left hand side. Right. First we do associative law because of same operation, union and union here. Then absorption law. Why absorption law? Because of this different operation, union intersection. Oh, sorry, not this one. Different operation. Okay, but have a same set, A prime. So you absorb, you got A prime here, and then union B prime. By De Morgan's law, you reach right hand side. Okay. So let's take a break, simplify these two statements, and prove left hand side equals to right hand side. Okay. This is question number 1A. So we start with relative complement, because this we got relative complement. Definition of relative complement: A intersection B prime. Okay, you can add this as A, right? So you get this expression. Alright. Then this we have a double complement, double prime. So using double complement, you got this statement. After that, using distributive law. Why? Because different operation and different set, right? Different sets. So we use you expand, right? Expand this set. You got this. After that, using inverse, say B prime and B, you got empty set, and then identity, because union, a set union with an empty set, you got that that set. Then using absorption law. Absorption law, why? Because different operation, see that different operation here, right? Different operation and same set, two sets, same set. So you got A. Okay. Next one is question B. First, using De Morgan's law. Why? Because we have bracket and a prime. So you open that bracket. So each set will take one prime. Then double complement. Right? Double complement. This one, double complement. Again, we use De Morgan's law because we have this bracket. So you open the bracket, give a prime each set. So here double complement, using again double complement. So you got this statement. Then using distributive law. Why? Because different operation and different sets. Alright, three different sets. So using distributive, expand. Then using inverse, A intersection A prime, you got empty set. Then identity. Lastly, identity. Right? Okay, now, last question. To prove left hand side equals to right hand side. So we start with left hand side. And you see this, alright, intersection. Now this one, intersection and union. Alright, and then different set. We can add this a set. This a set. And this another set. So three different sets. So using distributive law, here I expand. And then associative law, about associative to this one, intersection, so you can change the bracket. Then we have this prime intersection and another set prime. You can use De Morgan's law. You just alright, take the prime outside the bracket. So intersection change to union, and you also do this A prime intersection A. You got empty set, right? This one by using inverse. So there are two laws here, so just write two laws, inverse and De Morgan. And then after that, you use domination law. Domination law of this B intersection empty set, you got empty set. And then lastly, you reach the right hand side by using identity. Okay, I hope you understand about this one. So for exercise, please get the exercise questions from UFuture. So in course content, under my folder, Dr. Syamsatunaha Ahmad, and find laws of set theory. So these questions we will discuss in tutorial class. Okay, so for that, I end my class, my video with Assalamualaikum warahmatullahi wabarakatuh.